Hello, everyone. Welcome back to yet another episode of Medical Research with Mohan. This is Dr. Mohan Sharma, and in today's video, we'll explore the building blocks of research, namely population sample, variables, and data. Understanding these terms is essential for anyone interested in research, as it makes a huge difference in how you approach your research questions and draw conclusions. The main promise to you today is this. First, I will try to help you understand the concept of these terms rather than memorizing the definition, which will be short lasting. And secondly, we'll define and describe these individual terms and try to demystify some concepts surrounding them. Uh, when we want to build a house, then we need to collect this material, and these materials are, put together and a beautiful house results. Same thing applies, this building block. Unless we understand the concept of these building blocks, we will not be able to give a good final result. Let's start with the term population. Population in demography has a different meaning, whereas population in research has a specific meaning. It is defined as a group of individuals with at least one binding trait. In another way to describe population is this: all possible measurements of the particular characteristic under consideration is a population, and this population is of interest to the researcher. And the conclusion from the research study is research is applicable to this particular group, though there is a possibility of extrapolating the conclusion from this population to other as well. Let's take an example. If we are in, this is a group of people with disability, and this is one binding trait, and we take this as a population with disability. If we do our research on this individual, then the results of this research is directly applicable to them. Let's take another group of people with recent trauma, and if we do our research on this topic on them, then the results of this study will be applicable to them. The population is broadly divided into two types, as finite population or infinite population. In finite population, you will be able to count everybody in the group. For example, the group of students in the class, or the group of other people working in the hospital, medical persons working in the hospital, or every household in a village will be will be examples of finite population. Whereas infinite population, all people with headache, it is impossible to count how many people are there in Nepal with headache. Another people with diabetes, or patients getting admitted to ICU in a hospital. It is impossible to know how many will be there uh, in a year, or 6 months. So this is an example of infinite population. The reason why we need to divide them is, if it is a finite population, and if it is small, accessible, or the sampling units, the individuals are there cooperative, then you can take the entire set of the population for your research. But in clinical scenario, this is usually not possible. This is the reason we have to take a sample. That takes us to the next slide, which is a sample, which is nothing but a subset of the population. Uh, our aim as a good researcher is to make this sample representative, which means sufficiently similar to the population, so that we can draw conclusions quite confidently. Let's take the example here. A lady is cooking rice in a pot, and she's taking some rice in a spoon, and pinching the rice grain between her finger, just to make sure the rice is well cooked. She's very confident that if that rice is the portion she has tasted is well cooked, and then the whole rice from the pot is well cooked. Another example, let's take a steamer pot of mama and take some sample from there. Let's take 4 sample if the this momo tastes good, then the whole entire momos from this container must be of the same taste and good. If you notice in these two examples, the population is quite homogeneous. The lady has also fluffed the rice with the spatula, and in this pot also the momo looks quite homogeneous. So in such situation, if you take a smaller sample size, that may be sufficient to represent the entire population. Let's take another example of different sets of momo. You can have varieties of momos, and this population of momo is quite heterogeneous. And if you take a sample from there, if you take only this much momos, then it may not represent the entire population of momo here. So you need to add more momos to make it representative to the original sample. That takes us to the conclusion that you need a larger sample size to make it representative if your original population is heterogeneous. Let's define another two terms, parameter and statistics. This is a tree with apple, and we picked some apple and collected in a basket. So for the apples in the basket is a sample, and the apples in the tree is a population. So parameter is a statistical value that could be anything, mean, median, mode, or any other thing, calculated from all the values in a whole population. That is a parameter, whereas a statistic is a statistical value that is calculated from the values in a sample. So in this example, the mean weight of the apples in the entire tree will be the parameter, whereas the mean weight of the apples from the sample collected will be the statistic. So in clinical research, this value is unknown. In this statistic, this value is known, and our aim is to make it close to the parameter. Let's talk about the variable. Variable is its characteristic or attribute that you count, measure, or classify in a population. So sometimes people get confused whether what is a variable, what is data. This is what variable is. For example, height of the Burj Khalifa is a variable. If you see this monitor in ICU or operation theater, all the vital signs that are recorded are also variables like pulse rate, blood pressure, respiratory rate, oxygen saturation. All these are variables, and the color of the eye is also variable. And the value of a variable, which is known as data, varies from one subject to another. Like color of the eyes can vary from one person to another. Height of the building can vary from one city to from one building to another building. Similarly, pulse rate or blood pressure varies from individuals to individuals. Let's look at this table. Now we have a small example how it is done. So we have population, age in years, sex, and heart rates. So person one is 45-year-old female, and her heart rate is 70 beats per minute. Another person who is 47-year-old male, and his heart rate is 80 per minute. Third person who is 58-year-old male, his heart rate 65 beats per minute, whereas the person 4 is 61-year-old and a male, and the heart rate is 60 per minute. So in this example, age in years is a variable, sex is a variable, heart rate is a variable. How about the data? Data is defined as observations or measurements that have been collected for a variable. So definition is quite obvious. And also another way of defining it is knowing it is a value assigned to a variable. So same example of the table in the previous slide. So this is the data, and the variable we had described in the earlier slide, and these are the data 70 beat per minute, 80, 70, 65, or 60, and all female, male, and the number in year. This is collectively called data. And if these individual points, 61 is a data point, male is a data point, 80 per minute is a data point. And the entire set of thing is called data set. So the more data set you have, the more information you can derive from the data. What are the properties of data? Data make the basis for reasoning or calculation. And data is considered the lowest unit of knowledge, but unless analyzed is useless. Data, if you collect data and leave it alone, it has no meaning. And third important point is data without variable is useless. I will give an example. Again, the same data set we have. So here, everything makes sense. As a person one is 45-year-old, it makes sense, and is a female, and she has a heart rate of 70 per minute. Let's cover this and see. Now the variable are taken away, so this 45 has no meaning, whereas 70 slash m also has no meaning, and f and m also has no meaning. The data suddenly lose importance the moment variables are taken away. What is primary data and what is secondary data? Primary data is that the data acquired directly from an original source, for example, from a field observation or measurement, or directly collected from the real clinical setting by the researcher himself or herself. Whereas secondary data is the pre-existing data from an agency or other source, or hospital chart, or records kept in the operation theater, ICU, or ward. These are the sources of secondary data. Let's talk about the classification of the variable. The reason why we need to classify variable is there are different approaches for summarizing and visualizing data, and there are the statistical tests are also different for different data types. These are the reasons, and the classification is done based on the roles they play and how they are measured. Let's classify them based on the rules they play. Broadly, they are divided as independent and dependent variables. Dependent variable, also known as predictor variable or explanatory variable, is that variable that potentially influences the other variable. So independent, whereas the dependent variable, also known as outcome variable, is the one that is affected by the or influenced by the independent variable. So these are the examples of variable we had also discussed in the previous slides as well. Age, obesity, alcohol consumption, wound infection, and many more you can describe as variable. Please note that same variable may be independent or dependent depending upon the context. It is up to the researcher to assign a variable as independent or dependent based on your research question. Let's do some example here. In this, the age, the older a person becomes, the chances of that person become obesity is high. So in this particular research question, or we can put a question like the age also increasing age associated with the risk of obesity. In this research question, increasing age is an independent variable, whereas obesity is a dependent variable. Same obesity, if we talk about whether being obese is a risk factor for diabetes, then obesity is an independent variable, whereas diabetes is a dependent variable. Another example is solitary lifestyle is a risk factor for increased alcohol consumption. For that research question, solitary life is an independent variable, whereas alcohol consumption is a dependent variable. In another situation, this alcohol consumption becomes independent variable when we talk about the risk of brain hemorrhage, whether the person with a large alcohol consumption or alcohol dependence have an increased risk of brain hemorrhage. So it's up to the researcher where they want to put this variable as dependent or independent. So another way of classifying variable is based on how they are measured. Basically, they are classified into three broad groups like categorical, numerical, and time to event variables. We will discuss this concept in detail in the subsequent videos. Just to summarize today's video, population is the entire set of items or people. Sample or subset of population should be as similar to population as possible. Variables and data are the core building blocks in research, and a good understanding of these building blocks of research is essential in carrying out the research successfully. Thank you for being with me today. Hope to see you in next video. Bye.